All right, so confidence intervals for slope. Now, I normally in class, I would have in that first lesson done more of an intro with some like sample problems. And so we kind of just jumped into it. And when I was talking with a few of you, I realized I didn't really give a very good heading of where we were headed. That was a dumb sentence. So here is kind of what we're doing. Do customers who stay longer at buffets give larger tips? So yeah, what kind of study is that? You know, difference in means, difference in proportions, homogeneity, chi-square. See, that's not. It's like questions we've had, but it's not actually exactly any of the questions we've had. And so that's what chapter 12 is asking, that kind of thing. Which is the same as saying, basically, is there an association between how long people stay at a buffet and how large their tip is? But it's different from chi-square because now it's all quantitative, and so we can say, we can give a direction. As one goes up, the other goes up, question mark, maybe? Well, we'll ask Charlotte about that in just a minute. But first, what is the formula for constructing a confidence interval for slope? Well, I copied the main formula here from the formula sheet. So what is our statistic? Well, the statistic we are going to use, we're trying to estimate the true slope. So that would be beta. So we're going to use whatever the slope of our data was. So we just type in beep, boop, beep, and usually they give us the computer printout. So in this problem, we would use that number, 0.03013. Okay. Plus or minus the crit value. Well, based on the rest of the question, it's probably going to be a t. And that's because we are not going to know, when I do the standard deviation of the statistic, we are not going to know the real standard deviation, and so we have to use the formula for the standard error of the slope. So our t star, and then I'm just going to put standard error of the slope. So standard error of slope like that. Because we're not going to have to calculate that using the complicated formula. It's on the formula sheet. But they will all, I can't remember actually doing that on a full like panic problem ever. And so usually they'll just give it that to you in the computer printout, which down below is this number right here. That's the standard error of the slope b. That's, remember, the second row is all the b's. Okay. Where do you get the value of t? Well, you could just check your Joule app or whatever. It probably has t on there. I almost couldn't even say that joke. I just made that up right then, like in the middle of that sentence. You could probably tell. Oh, well, there's a table for that, actually. And it's even called the T table, or table B. Table A is the z-scores. So T table, okay. Or on the calculator, T CDF, or no, oops, just kidding. Inverse T. TCDF would give you the area to the left of T. But the key for all of this is not on printout. And if yours is right below it like this, I don't know if I have the exact same copy of the notes as you do. Not on printout, exclamation mark inside that probably. Oh well. So it's not that number. That says T. But that is a T that we will use for like phantom problems, maybe, but not here. And then this question also asks how many degrees of freedom, and of course that is also different, and so now df equals n minus 2, and oh man, so we got n minus 1, categories minus 1, rows minus 1 times columns minus 1, and now n minus 2. That's kind of confusing. So n minus 2 is kind of because you have two variables, and so you can never have, so you need at least like 3 things in order to work with this, or so. You'll just have to remember that. It's likely to not even come up. but, well, I mean, it's going to come up, but maybe not on the AP exam. Okay, so do customers who stay longer at buffets give larger tips? Well, Charlotte, an AP statistics student who worked at an Asian buffet, decided to investigate this question for her second semester project. Maybe you guys should do one of those. She was doing her job as a hostess. While she obtained a random sample of receipts, which included the length of time in minutes the party was in the restaurant and the amount of tip in dollars. Output from a linear regression analysis of these data is shown below. Okay, the first part of this is going to be a whole bunch of review, and then eventually we'll do panic. So, these are all, this is the y, my pen ain't working. This is the y-int, and this is the slope, and this is the standard error of the slope, and this is not used yet, but actually it will be for phantom, but not for panic. And then this is r square adjusted. Oh wait, no, we don't want that. This is r squared, and this is standard error, standard deviation of the residuals. I don't know why I'm underlining all of this when I have the little laser pointer, but it's too late. The first graph has time on the bottom and tip in dollars on the side, so that is just the scatter plot of the actual data. Apparently, she had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12-ish receipts. Then we have a residual plot because I have residuals on the side, and it's going straight through. 0. And then we have the residuals on the bottom and the frequencies. This is a histogram of the residuals. Okay. What is the equation of the least squared regression line for predicting the amount of the tip from the length of the stay? Define any variables you use. I'm not going to use any variables. I'm just going to write words. Predicting the tip. So I want to predict this. So tip hat is equal to the y-intercept from the chart up there that I already labeled, plus, because it's positive, 0.03013, I'll just write the whole thing, times the slope. So I could do y hat and x, and this is a and b, a plus bx. But I will just do predicting the amount of tip from length of stay. So I'll just call it length. Why not? Okay. And I don't need to define anything. Okay. Interpret the slope and y-intercept. Okay, the slope, I'm going to just type this one out. We predict that a party will tip an extra 3 cents per minute of time per minute spent in the restaurant. Or we could say the predicted tip amount goes up by 3 cents for each additional minute spent in the restaurant. So I kind of went with a combination of the two. Of the two that I said. Now the y-intercept, that was the other number, which I can't see anymore. So 4.535, and we would just say we would predict, right, always the word predict, that a party that stayed here for 0 x's, so 0 minutes, would leave this much tip. Maybe we shouldn't have said it with so many decimals, because that doesn't really make sense, but I already did it. Interpret the values of s and r squared. Okay, r squared is the big crazy one, but s is pretty easy. When using r line to predict the tip amount, to predict the y variable, we will typically be off by this number, $1.78, and that came from up here, this underlined number. Okay, r squared, that is the big complicated one, where we say, let's see, r squared is 13.2%. Sometimes that's not as a percent, and so we say 13.2% of the variation in the y variable, so in tip amount, is accounted for, is the phrase I usually use, by our linear model, by the LSRL, relating tip amount to minutes spent by a party of patrons at an Asian buffet, or something like that. I'm going to simplify that a little. Or maybe I won't really simplify it, I'll just stop writing. Okay. Interpret the standard error of the slope. Okay, so that's a new one from chapter 12. Those other ones were chapter 3. So this is, again, simply the something typically differs. And so we'd say the slope of our standard or our sample regression line will typically differ. Now, this is a little weird one because we only have one slope. But if we were to do this many times and got many slopes, then the slopes of those. So the slope of our standard sample regression line will typically differ from the true slope, or the slope of the true regression line or population, by about 0.02448, which was labeled up above. I'll show it to you in a second. Okay, and I'll come right back to that. But up here is it's that highlighted number, 0.02448, because that's the standard error of the y-intercepts. We never actually use this one, but we could, but we don't. And then the standard error of the coefficient of slope. Okay. Now, full out panic. Calculate and interpret a 95% confidence interval. Oh boy, how much room we got? Wow, not a lot. Okay, so for the sake of not having a lot of room, I think I'll just skip the P. We want to estimate the true slope of the population regression line relating these two things. A, we need to spell linear. So linear, the scatter plots is roughly linear. I'm going to type these again. Okay, independence. Well, how many did she have? 13? She took a random sample of tips, so... Okay, actually I went back and counted them, and so there are 12. So assume at least 12 times 10 equals 120 receipts that she could have chosen. Normal, the histogram of the residuals is roughly symmetric. So one of the keys with linear is that we're other than the scatter plot itself looking linear, everything else has to do with the residuals. And so to go back up here, so I'm talking about this picture here, roughly linear, or roughly symmetric. I mean, it's kind of skewed left, if anything, because you got that peak on the right, but we're also talking about such a small n, which doesn't really matter with these, because, anyway. Okay, E, the residuals are, the residual plot shows equal spread throughout. And I should say approx equal, not actually equal. And you have to prove that, well, but they gave you the residual plot, so let me again scroll back up here. So yeah, so here they're not clearly, there's no pattern where they're like really close over here and now they're more spread and now they're close again. Like, I mean, you kind of could say that pattern, but there's like this one, and normally it's like they're not like a Christmas tree, or like the helicopter one where they're the same, and then one was really wide and then the same. So that's all we're looking for there. Both of these kind of new conditions, well, actually here, just real quick, well, and then random. Let me finish it. So random, I'm just going to check. Yes, she took a random sample. I don't feel like writing it. So random is still so it's not biased. And independent is still so that I can use the right formula for spread. But the equal standard deviation and the linear are both kind of that too, because the formula for spread is much more complicated on these. And so the L, the I, and the E are kind of all about that. And then the N is still to say I can use a t-score because I have symmetric data. So, okay, so P, we want to estimate the true blah, blah, blah. A, linear. N, like of the word phantom or panic. Wow, that is not an N. Is name the test. We will construct, not do, construct. We've been doing tests with chi-square. We will construct a, what is this thing called? I haven't taught you that yet. So we're going to call it just simply a t interval for slope, or you could put beta, and that's it. And then you know it's chapter 12 because slope. We're not talking about x bar, p hat, chi-square. No, we're talking about slope. So there you go. And then these are usually pretty, well, actually, I was going to say pretty easy to notice, except they can be kind of hidden. So then let's see. I in panic is find the interval. Okay. Now, there is not a nice, simple way to do this on the calculator unless they actually give you all the data, and then you can put them in L1, L2. That's the last question on this notes. But so we need to just get it, I guess. So what was our B? We have all the data. It's not too hard. So our B was... this 0.03013 plus or minus our t-score and our standard error. That's easy. Our standard error is 0.02448. 0.02448. Now our t-score, I'm going to do inverse t on my calculator. And what are we going to type in? It wants area and df. So my area is going to be, what did they say, 95%? So this is where if I can't specify, I do half the tail area, so 0.025 and a df of 10. And that gives me, so I do 0.025. And that gives me negative 2. Oh, but I don't want the negative. I just want the positive version. So, oops. Because the plus or minus takes care of the negative, because you're doing both. You also, for that, could do the t-table. I actually recommend the t-table here. Just make sure you go to the right df. I just don't have it handy. Actually, I probably do because it's in the back of the book, but whatever. Okay, and then I just type all that into a calculator. So the margin of error timesing those was 0.0545, and then I just take that number plus 0.0313, and then that number, well, 0.0313 minus that number. So I got negative 0.0244 to 0.0846. So what does that mean? We are 95% confident that now normally we say the true something, the true mean, but it actually wouldn't be necessarily wrong to say that. But here we usually say that the slope of the true line or population technically, to get your context, you really should say relating these two things, stay length and tip amount. We are 95% confident that the slope of the true regression line is, well, actually, I guess I say that the interval captures the true, so is between, and then I would just list my interval. And now, this whole question was really asked as a question. This should have been a test, but it told us to do panic. But it should have been a test. Is there a correlation here? Do people who stay longer leave bigger tips? And so what we're really asking, based on this interval, is there convincing evidence of an association? This is where it gets tricky, because that sounds like chi-square. But the difference between this and chi-square is I don't have a two-way table. I have a bunch of stuff about lines, and I'm dealing with all quantitative variables. So another way they might say this is there convincing evidence that a linear model is appropriate, or something like that? And so, does it seem that, well, yes, our sample slope was positive, meaning the more you stay, the more you give money. The majority of our interval was positive, but it was plausible that the true slope was actually negative. And so, what are we looking for? We're looking to see is 0 in the interval. And so, is there convincing evidence? No. No, because 0 is in the interval. And 0 would mean that there is no association, basically. It would mean that there is no real slope between these two. You couldn't actually graph a line. And our R square was pretty weak, right? It was only 13%. That's pretty small. And that's typical of these. You're looking for something that has a slight relationship. So there's a correlation, but there's not a very strong correlation. And then I mentioned this earlier. Can you use a calculator for the do step? Not very easily. Only if you have all the data. And if you have all the data, you use L1, L2, because you have to have two variables: length of time, tip stay, and then you do a let's see, what's it called? Lin regression test. No, t-int under the stat tests. And there's also a t-test that we'll do for our last part, which is phantom. Okay, so then the homework 7, 9, and 11. Well, really, I should call it bookwork, not homework. 7 is just a continuation of the prey and predator that you did in 3 and 5, and now you're just making a confidence interval and doing another interpretation from chapter 12 instead of 3. And then 9 and 11 are part of one problem where you're doing a full panic, except you get to skip the A if you read the directions. You also don't have to do the A for number 7. You don't have to check your assumptions. Oh, you already did that. That was number 5. That's right. And then number 11 is like a follow-up of, actually it's more like a chapter 3 follow-up. So it's really only 2 kind of big problems, or yeah. So hopefully you can get those done and get a picture of them and it makes sense.